Hello, this is assignment 3 part 1. In the first question, we were asked to divide into pre-WI and post-WI. I divided into pre and post based on the file ID's first 4 letters. In the second question, we were asked to normalize the text. So every word in pre and post-WI are converted into small letters using W dot lower. Third step, we were asked to calculate the frequency distribution of unigrams and bigrams. So usually pre-WI whole list would consist of all the frequencies and its corresponding word in pre and post WI respectively. In the next in this cell, I took the most frequent, most common 200 words for pre and post and appended into a list called X. So for every word in X, all the stop words and words length greater than less than 2 and the duplicate words are dropped, and finally it consists of 161 words. So for every word in most frequent word, its corresponding probability from the pre-WI whole is appended to D with both word and its probability. If the word isn't there in pre-WI whole, then 0 is added accordingly and both lists were merged. In the similar way for post, I calculated it, and these both lists were converted into pandas data frame, merged, sorted in the ascending order and saved to a text file. The same logic was used to generate bigrams frequency distribution, just that I have calculated the most frequent words for 1000 instead of 200. The logic was the same. In the next question, we were asked to identify 50 with largest difference. So I took the bigrams for pre and post and dropped all the stop words and words less than 2. And I have converted them into pandas data frame, merged them in for rows where the value is null. I have filled them with 0, calculated the difference between pre-WI probability and post-WI, and sorted them in the descending order and took the top 5 and visualized them. So this is my graph after visualization. Make CF test was given. So using this function, we have this function returns unigrams and bigrams with their corresponding frequencies. So I removed the stop words in this step and call the function which returns list of unigrams and bigrams with their frequency. So I have calculated the PMI for pre-WI. So this calculation is based on this. So frequency of bigram. So this was taken from bigram, both word 1 and word 2, how many times they were appeared, divided by n. So this n and this n would cancel. So I used frequency of w1 and comma w2 into n divided by frequency of word 1, word 2. So the frequency of word 1 and word 2 are C and D. So I divided C into D and replaced it stored into F. And I did log of E divided by F. So E consists of frequency of both word 1 and word 2 together. And it was multiplied with N and stored into E. So taken to the log of 2, and this is how I generated the PMIs for pre and post and filtered them to find at least one of the word in the bigram is economy. I have sorted them in the decreasing order of the PMI score, took the top 45 and saved them to a text file. So these results would be different from the one shown because I took the most frequent words. So in assignment 3 part 2, in the first step we were asked to combine the text 2, 5 and 6, and in the next step I have calculated the Laplace smoothing. So this is the one most. So in the first we were asked to so CPD is the parameter that is that is given from the Laplace smoothing. So this CPD labs is sent into this function as a parameter. Word is the word that I would like to start search with, generate a sentence with, and number of words to generate in a sentence, and the parameter. So if I send 0, it would find the highest frequent next word. So it's based on the max function, and randomly select next word. So CPD lab of that word, the dot samples, it contains list of all the next words. So I randomly choose one word each time, and that is set to the word, and that is printed to generate a sentence. To select the next word probabilistically, here also I generate a random number called xy. I assigned the cumulative probability to 0. I took the list of all the next words. To this list, I have appended the corresponding probability value for the word that was in the list. I loop based on those word and its probability, and each time I have added the probability value to the cumulative probability. If whenever xy, the random variable, the random number generated is less than cumulative probability, I would come out of the loop and take that word as the word and as the next word randomly. So this was the output that was generated from me using this. And then the last question, we were asked to do the same thing but with V. For highest frequency, it would be the same output, so I didn't loop. For the random next word, I looped it 5 times, and for selecting the next word probabilistically, I looped this. So the logic is same, but it wouldn't just break if come out of the loop if there is a full stop. And this is the final output. Thank you.